How are you guys? In today's video, we will perform motion analysis on chain and sprocket by creating parts, then assembly, motion analysis, and exporting video. Further details are given in the chart. So, if you are new to our YouTube channel, kindly support us by subscribing, sharing, comment, and liking. Thank you very much. Okay, let's start. We have created a chain and sprocket folder here to stay organized, and we will open the SolidWorks. Okay, select part and let's save it. Save it in the same folder that we have created. Save. And now we will open the design library. Design library toolbox add in now. And we will move to the ISO here, power transmission elements, chain and sprocket. Here we can select any one. The basic design is the same, but we will select this one. Drag it here, click, yes, click again, yes, okay. Now we have imported the sprocket here, you can see, and you can design your own, but to save some time, we have just imported it. Now we will create a reference plane between these two faces. Click OK. And now we will start sketching on this plane. Right click, select sketch. Okay. Convert these entities, these three curves, 1, 2, and 3. Click OK. And now we will draw two slots like this. 1 and 2. Just like this. Okay. Now we will make relation between these two slots like this. Select these both and make them equal. Click OK. Let's see. Yes, they are in relation with each other. Okay. Let's give some reasonable dimensions to it. Let's try this one. No. Let's try another one. Uh, okay. Now this looks reasonable. Okay. Now we will draw circles. Yes, circles. This center, and we will make sure that it coincides with these curves. Right? Okay. We'll draw some other circles like this. And the third one here. Okay. Now we will make relations between these circles. They are already equal. So, okay. And we will make some relation between these two circles as well. Maybe equal. Okay. Yes, equal. Okay. And then these two as well. Sorry. Okay. Equal. And okay. Right. Let's give some reasonable dimensions to it. These three circles are all the same. Exit the sketch. Okay. And now we will start extruding. Just follow these steps. We will select the contours, and we will extrude it from the face of the sprocket. Okay. And we will make sure that we do not merge the solids. Okay. We have again selected the sketch, and now we will extrude it like this. Okay. And we will extrude it up to this surface. And we will untick the merge results. Okay. And then we will go for extrude again with the same sketch. Okay, first of all, let's see, we haven't merged the results. Yes, we haven't. And okay. Then we will go again for extrude using the same sketch. And we will select some different contours. Carefully selection will be done. Okay, like this. All right, looks good. And we will extrude it from this surface. Okay, and take this option and click OK. Okay. Now we will uh, use the extrude another time using the same sketch. Okay. This time we will select these contours, right? Like this. Okay. And untick this option and select this surface. Okay. Now we will mirror these bodies, right? Select this as a mirror plane and we will mirror these bodies like this. Okay. Select this one also. All right. Click OK. Now we have mirrored it and we have made the links for the chain that will exactly mate with this sprocket. All right. Now we will combine these solids like this by using the combine feature. Select these bodies. Okay, like this. Okay. And we will make sure that we have uh, selected the add option. Okay. Now we will use again the combine feature. We will select these bodies to make another link. Sorry. Okay. Select this one and same as this one. Okay. Let's check it. It's good. Okay. All right. Now we have three separate bodies. And we will save this part as an assembly. You can see here we have three separate bodies. We haven't merged any of it into each other. And now we will save it as an assembly. So select this one and click on browse to save it. Save. Okay. To save it, click OK. Yes, yes. All right, now it is saving as assembly and these three bodies will be saved as separate parts as well. All right, this is the part and you can see the assembly file has opened automatically. All right, we will close it. Yes. Okay, now we are in this assembly. You can see we have three parts in it. I will show it to you over here. Okay, these are the three parts, two links and one sprocket. And this is the part that we started with. I will delete it to avoid any confusions. Okay, so these are the parts and assembly we will be working on. Okay, so we will do some editing in this part, the sprocket. First of all, we will make a hole in this. That will make it easy for us to mate in the later steps. Okay. So now we are creating a hole in the sprocket. We have made a sketch on the face and now we will cut extrude it. Okay, up to this surface. Okay. And now we will create a mid plane for this sprocket. For that, we will select these two faces and here we have the mid plane. It will be useful later. And here we will make a point as well in this sketch that will help us in mating later. Okay. Make a point and click OK. Save it. Okay. Exit the sketch. Yes. Yes. Okay. Now we will open this or we can open it from the folder as well like this. Okay. And in this, we are basically making a mid plane just like we did in the sprocket. Okay. Select reference plane and select these two faces and by default a mid plane will be constructed. Okay. And save it. We will exit. Okay. Now same for the other part as well. Open it and make a mid plane for it. Select reference plane and now select these two faces like this and click OK. We are done. Save it and exit. Okay. Now we have created the planes, the mid planes, like in this part, in this one, and similarly this one also. Okay. Proceeding further, we will make it float. By default, it is fixed. So we will remove these two links. And now we will start the mating part. And we will mate the midpoint of the sprocket with the origin. Like this, we will make it coincide. Okay. Okay. You can see it is coincide, but it is still dancing. So to constrain it, this dance, we will coincide the right plane of the assembly and the mid plane of the sprocket. And now let's see, yes, it is just rotating and now we can proceed further. To create a profile for the chain, start sketching in the right plane of the assembly. We will draw a circle like this, and we will make sure that it coincides with the center of that small curve. Okay, now uh, we will make a line between these 2 points, which will be the center of these two curves, one this and another one here. Okay, you can select any two curves of the sprocket teeth, um, but we have selected this one. Now we will draw a line like this, and when it is done, we will make a relation between these two lines like this one, and make it equal. Okay, they are equal, and now delete this. Okay, now this is the length of the uh, chain link. Now we want 6 links, so we will multiply it by 6, and we will get the length for it. This is an automatic method to do it. And now to mirror circle, we will create this line, and we will mirror it. Okay, we will mirror this circle, okay, about this line. Okay, and join these 2 points of the circles like this. Okay, now we will do some trimming. Trim this and this one also, and this small line as well. Okay, okay, and now we will convert it into an spline. Okay, select this region, and you can adjust it at your own ease. And okay, okay, and we want to get rid of the geometry, so delete it. And okay, now we have the spline. Trim this one as well. Okay, and exit the sketch. Now we have a profile for the chain. So now we will rename it temporary. The temporary means that uh, in the main motion analysis, this path will not be followed. Now we will select the chain pattern, and here select the two links pattern, and for path select this, and for the first one select this, and these two cylindrical features. Okay, and in this we will select the mid plane that we had created, this one. Okay, they will align through the path using this plane. Okay, now the other one. Okay, let's select the two cylindrical features, this one and now this one. And similarly, we will select the plane that we had created, this one. Okay, and now we will, okay, fill path. Okay, and basically we have two options, one is dynamic and one is static. We have selected the dynamic. Dynamic means that we can move it like this, and now we will dissolve the chain pattern, right? Basically The chain pattern helped us to put the links in the right place for the chain. So we will dissolve it and we will now fix it so that it do not move. Okay. And after making the whole assembly fixed, we will start mating the chain links. Since the whole assembly is fixed, while making the chain links concentric like this, for one link you will face a problem which will say that you need to break some mats. So you will just leave that mat and you will not mate that links or make it concentric, and you will just continue the other links to make it concentric, right? Don't worry, just follow us. Okay, now we will make this one and you will see we have a problem. Yes, it says you need to break the mat to proceed. We will cancel it and we will make this one at the very end. If you face the same problem, just leave that mat at the end. Okay, now we have done all the mats, the concentric mats. You can see we have created the concentric mats, and now we will mate the one that had a problem. But before that, we will make it float like this. Okay. Now we will mate this just like this, right? Concentric. Okay. Now the tricky part has been done. You don't need to disturb the chain right now, right? Save it. And now we will make it fix again. Okay, now we will float it, and uh, we will make another sprocket by control and click. We can make a copy, and now we will proceed further maths. Okay, now we will mate this plane with the right plane, right? And now we will make it concentric with this one, and similarly another one also. We are basically positioning the parts in the right places. We will delete some of the mates, but these mates are basically to put them in the right positions. We will delete it. Okay. Now we will make another sketch on the top plane of the assembly, right? So that we can make an axis of rotation for that sprocket. Okay, this one is done. This one is not necessary, but uh, we will make a pair of it. Okay, it horizontal. for construction and finite length. Okay, and this one is the basic one. This is important. Okay, all right. Now we will make the sprocket concentric to this axis. We are almost done. Okay, we will reposition this one as well so that we do not face any problems in the motion analysis while making the contacts. Right. We will delete this one as well because this one was only just for the positioning. Okay, now we are almost done. But there are some other mates, important mates that need to be done. For that, we will make it float and we will basically mate the right plane of the assembly with the mid planes of all the links. We will mate. Okay, the chain has 20 links and we will count that we have selected all the 20 planes to avoid any errors or inconvenience. Okay, it's good. And we will make it concise. Okay. It looks tedious, but believe me, it's worth it. When you perform motion analysis, you will save much of time with these tricks. Okay. Now we will add some uh, colors or appearances here. And in appearances, metals, steel, and you can give any of the color to it. Okay. Now we will proceed to motion analysis. And here make sure that no part is fixed here. All the parts should float. Okay. In SolidWorks, add in select motion analysis and from this drop down, select motion analysis and uh, now select some timing for this analysis by dragging this key. Okay, from these options, we will select add here to save time. You can select other number, we'll change the 3D contact and okay. We will apply the gravity with an appropriate direction here, negative y-axis. Okay. All right. Now we will make the contacts, which is very important. Go to the selections, tick that and select the whole assembly. Deselect these two from the pink list and add it to the blue list. Okay. We will deselect the material and friction to reduce the time for calculation. Okay. And now we will add some motor here, reverse the direction and change the RPM to 20 or something like that. Okay, right. Now we are set and we will calculate and wait for the results. It will take some time depending on your machine, and it is started. All right, the analysis has been done and let's check it. Right. Uh, as I am moving the cursor, the animation is disturbed. But it's okay, fine. The results are here. You can see it. The right sprocket was driven by motor and it in turn drive the chain and the chain in turn drives the left sprocket. I hope you like this motion analysis and you can try it on various chain and sprockets. Right, we can save it, but first we will add a camera to capture the details and save it in a video. So right click and add camera and then go to camera, right click properties and here zoom out. We have two windows. This one is for sitting. The camera, you can move it freely as well. And this is the window which can zoom in and zoom out. And uh, this is the target, right? You can select a surface or a body so that it should be only focused on that part. This is an important point. Here you can select different ratios for the output results. Here you can select different, but 16:1 is the standard, so we will go with it. Okay. Uh, all right. Now we will draw a curve for the camera so that the camera will follow the curve and capture the chain and sprocket. So we will draw the curve on the top plane. We will draw with a spline and just follow the rest. Okay. Now we will edit the properties of the camera at 0 seconds and zoom out. Select this one and click the curve to adjust. Now you can move the target point, but it's not moving. What's the problem? Okay, delete this selection and now you can move the target and you can see the output result on your right window. So adjust accordingly. Okay, it's up to your own creativity and your own settings, right? Okay, now move the slider so that we can add another key at this time and just right click on the camera properties, uh, zoom out and we will move the camera on the curve by doing this like you can see. Okay. We will do it step by step. we have added another key, right? So you can see the results better. Okay, now we have moved the slider and now we will edit the properties of the camera once again and we will move this to up to here. Okay, the camera has moved. You can see. Okay, so this is or another key. Now let's add another key. By making new keys, you can also copy and paste the old keys as well. Like I will copy this one and paste it here. So the camera between these two keys will not move. Right. Now we will add another key. Zoom out and move the camera further. So key is added and now we will move the slider again and we will copy this key and paste it here. Okay. Now we will add the final key by editing the properties and dragging it to the final position on the curve. You can see, okay. Now you can see the empty spaces between the keys. It means that the camera will not move between those spaces, right? And now right click here and camera. Okay, camera view is now on. So this result will be saved. But before saving, let's hide the unnecessary sketches. And before that, make sure that you drag the slider at 0 seconds, right? And then camera view, sorry, we will on the camera view and we will hide the unnecessary sketches. Okay, hide it one by one. All right, now save the video. Give an appropriate name. Mm. Here you can see the ratio 16:9. It is logged. You can't change it because you have already selected it in the camera view. And this is the frame rate. And save it. Okay. And we will wait for it to save. Okay. It is now saved and we will see it in the folder. Let's open it. And this is the result. You can see it. Hope you will like it. So here we have completed our tutorial and we hope you will like it and you will have learned something new and valuable from our video. So here we will wrap up our video. If you still have any problem, please let us know in the comment section and share it with your colleagues, friends, your juniors, students, everyone, so that they can learn also and excel their skills, right? And you can try many things as well. You can increase the contact resolution between different parts in the motion analysis, and you can try some new things by applying the motion analysis to new assemblies and new things. And we hope we will be connected. And thank you for watching. And see you in next videos.